Hello! We're going to take notes on the periodic table of the elements. Please have this page with you at this time. First, I just wanted to show you this really awesome periodic table. I love this periodic table because it shows you an actual picture example of all of the different elements, and it makes me happy. Okay. So, let's get to our first question. How is the periodic table arranged? Why are they arranged like that? Well, the elements are in order of atomic number, so increasing atomic number. So, right up here. And a little bit more about that. The elements are grouped together based on their chemical and physical properties. You can see they're kind of color-coded, and that is going to tell you some more about those groupings. We're going to get more into the families and stuff in another video. Okay. Now, let's talk about how we actually read the individual blocks, an element block on the periodic table. You're going to fill that in right on here. So, the first thing, the most common piece of information that you're going to find is the atomic number. It's usually at the top of the block, or sometimes it's right underneath the symbol. It's always going to be the smaller of the two numbers that are going to be given on the block. And it stands for the number of protons that are in one atom of that element. Next, we've got the symbol. And so the symbol is usually the first one or two letters of the name of that element. And so we've got gold is, it's AU, which is not the first two letters, but the Latin name aurum is where that symbol comes from. So any of the ones where the symbol doesn't match the name, it's coming from its Latin name instead. Next, of course, is the element name. That is the common name that we use in English, the chemical name of the element. And then last, we have the average atomic mass. So the actual atomic mass of an atom, that is going to be the number of protons added to the number of neutrons that an element has. And now most nitrogen atoms are going to have 7 protons, which we know from the atomic number. Most of them are then also going to have 7 neutrons, but not all of them do. Some of them actually have 8 neutrons, and so they have an atomic mass of 15. But there's just very, 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 very few of those that exist in nature. So if we average all of the nitrogens up, their average mass is actually 14.007. So not quite 14, a little bit over 14, but not very much. So that's where the average comes from. Okay, now let's talk about the 3 different types of elements. At the bottom of this page, you are going to have a table, and in that table, you're going to list the type of elements here, so the metals, nonmetals, and then the metalloids, which are also called semiconductors. Then you're going to list the most common state of that element, and so what I mean by that is solid, liquid, or gas. And then last is the physical and chemical properties that you're going to list on the end. Okay. Let's start by talking about the metals. Now, you guys know most of the metals are solids on the periodic table. Some other things about them. So almost all of them are solid. They are also malleable and ductile. Malleable means flexible, means that you can move them around, which is not usually how we might consider a piece of metal to be. Here's a nice little Allen wrench. But you can actually bend these things. Sometimes it takes a lot of force to do that. Sometimes we have to heat them up to make it easier to do that. But you can bend them, and they don't snap. They are also ductile. So the example of ductile here, that's these wires. So copper wire is something that is ductile. Here, I'll show you guys some copper wire. I have some on hand. Ha-ha! Look at that. So copper, of course, is more malleable, and ductile means that it can be drawn out into this long wire. That's not something that lots that elements that are not metal can do. Also, of course, they conduct heat and electricity. We all know that part. Okay, I wanted to show you a couple of elements that are not solid at the average temperature and pressure that the Earth is at, and those are gallium and mercury. Gallium is really cool. You can actually buy samples of gallium on the internet. They're available. It's not poisonous or dangerous to you, but it is kind of expensive. And then mercury is something, it's also going to be a liquid, but it's actually toxic if you inhale the fumes. It can be very dangerous to your brain, and it actually causes people to go insane. Like it causes you to lose control of your mental faculties and everything. Mercury, some of you may know that mercury was used by hat makers to actually like make, hats for your head. It was used by the machines that would form them and fit them, and it made the people that made hats, who are called hatters, go crazy, which is where the Alice in Wonderland character, the Mad Hatter, got their name. Mad Hatter, because the mercury makes you go crazy, and mad is like the British for crazy. Okay, now let's talk about nonmetals. And I wish I hadn't chosen that picture because it looks so tasty. But nonmetals, they're not malleable and flexible. They are brittle. If you try to bend them, they snap, they break, like delicious peanut brittle. Most of the nonmetals that are on the periodic table are gases. Some of them, like sulfur, that's actually a solid. It's this yellow, chalky substance that smells like rotten eggs. It's pretty gross. It actually looks kind of like an egg yolk, and it smells like a rotten egg yolk. So, there you go. But most of them are going to be gases. Iodine is a liquid. Bromine, I think, is also a liquid. You can get chlorine. Chlorine comes as a gas, and sometimes it comes as a liquid as well. It depends on how much pressure it has on it, but most of them are gases. So that's what I'm looking for on your notes. And then also for the properties, they don't conduct heat or electricity. So for properties, brittle and don't conduct heat or electricity. That's what I'm looking for there. Okay, last one we have is the metalloids. They're also called semiconductors, just another word for them. And so on some periodic tables, you'll see them listed as metalloids, and some periodic tables, you'll see them listed as semiconductors. They have a mix of metal and nonmetal properties depending on the environment. So that's really what I'm looking for in terms of properties. They have a mixture. It depends, but it depends on the environment. So here are some examples of the different elements. There's just these, and so it's boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and acetine. Yeah. Used in computing, and so what that means is they're used in making computers, and there's all sorts of different little electronic devices. Here's a few. There's a capacitor. I think that's a resistor there. Some different LED lights, switches, and they sometimes allow electricity to flow, and sometimes they don't allow electricity to flow, and that's really why computers work. This is a giant wafer of silicon that's used to store information, to store electronic data. Okay. Now, on the back side, if you guys would take a look at that, I want to talk about what the numbers across the top and on the side are for. And so those are called groups and periods. So on the top, these are the groups, and on the side, these are the periods. So the elements that are in the same group, those are all going to have similar physical and chemical properties. So for example, when we talked about the alkali metals, this first column, we tested sodium and potassium in water. They both react with water in that they explode or catch fire or combust in water. Um, and we saw as we go down the periodic table that reaction got bigger. And then if we kept going into cesium and rubidium and francium, we'd see it get even bigger than that, which is why I'm not allowed to buy it. And so we see in the individual columns, that's where we see things in common. Also, in this middle group, a lot of those have things in common as well, and it gets a little bit more mixed up, but there are still some patterns that are in there. They're just a little more complex. Now, the rows, we see that properties repeat themselves in each row. So the properties are repeating in each of these rows. And like I said, this middle chunk is a little bit more awkward, but the patterns that we're looking for mainly repeat in those rows. Then we have the awkward rows down below that don't fit in. And the reason that they're down below is because this is kind of awkward to have on a piece of paper. You'd have to have a really long one or 2 pages put together, and so it's just easier to have it the other way around. If you guys will sketch that general shape, you don't have to have it like exactly every single hump and bump in the right spot, but if you would give me that general shape as the last thing on your notes. Finally, I just want to show you this website, which is really fun for me because I'm a dork, but it is ptable.com. So if you'll take a look at that, just type that into your browser, ptable.com, and it'll take you to this website. And I love it because I can highlight the different families and see, here are just the metals. Here are just the lanthanides, which are way down there. Here are the metalloids, the other metals, noble gases. So there's all these different kinds of things, and you can see their information. I love playing with the, or if you click on one, it'll take you to the Wikipedia page for that particular element, which is neat. Here's bismuth, which is a pretty cool one. Hey, good old oxygen. Woo. Yeah. Look at that. Liquid oxygen. Do you guys see the color? It's blue. Liquid oxygen is actually blue. It's also extremely explosive, which is why I don't have it. I really like this properties tab because it shows you all kinds of different properties. The default one that it shows is states of matter. So the black are the solids, the red are the gases, and the blue are the liquids. And you can change the temperature. This is a really high temperature right here. Kelvins, that's a really, really high temperature. But if I bring it down to like this is like, well, it's still pretty high. Here's more of like a normal temperature. So you can see most things are solids. Oh, here's phosphorus was a liquid there. It's also a gas sometimes. Anyway, so these are, it shows you like where they freeze, where they boil. So that's kind of fun to play with. Yeah, so lots of fun information. You can do other types of things on here, properties, which can be lots of fun. So yeah, enjoy that if you ever feel like learning more about elements. Thanks for taking some notes on the periodic table. Have a great day.